Hello and welcome. In this video I will do a step-by-step implementation of 𝗂𝗃 using open addressing method and with linear probing. Okay, then I will do tests and find bugs and understand the problem and finally solve that problem. Okay, so the first thing we will do is create an item, a structure to insert in our 𝗂𝗃. Okay, here in the code we declare type def struct item, and this will be our item t, and it will have an integer that is the data and another integer that is the key. The next step is create the item, the function to create our item. So here we declare a function that returns an item t and is called new item, receives an integer key and another integer that is the data. Inside we declare an item t pointer that is the result and will be equals to malloc size of item t. Then we return the result, and here we say that result key is equals to the key that we received in the parameter, and result data is equals to data. Just this. Our item is almost done. Next we will free the item, a function to free the item. So right after new item function we declare a void free item that receives the item t pointer, that is the item that we want to free, and we say if item is different from null we call free item. Now that we have the structure and the functions for our items, we will do the 𝗂𝗃. So we declare type def struct and call it 𝗂𝗃, and this will be our 𝗂𝗃 t. Inside we say that we have an integer that is the counter, another integer that is the size, and a item t pointer array. Next we declare a function to create our 𝗂𝗃. We declare 𝗂𝗃 t pointer new 𝗂𝗃 that receives an integer size and as 𝗂𝗃 t pointer that is the result and is equals to size of 𝗂𝗃 t, and return the result, and we say result count is equals to 0, result size is equals to the size that we receive as a parameter, and finally we say that the result array is equals to malloc size of item t pointer multiplied by the number of elements, the size. And now we declare a function to free our 𝗂𝗃. Back to the code we say void free 𝗂𝗃 and receives a 𝗂𝗃 t pointer that is the table, and if the table is different from null we say for int I equals to 0, I less than table size I plus, and inside of the for we say item t pointer item is equals to the table at array at index I, and we say if item is different from null we free the item. Okay, then we free our table array, and after this we free the table itself, just that. So now we already declare the free 𝗂𝗃, and let's start doing things. First, let's remember what is open addressing. We have two numbers that we want to insert on the 𝗂𝗃, and inside of our 𝗂𝗃 we have an array, right? And then we have a hash function that receives our number, our key, and computes the 10 mod 10 because we have an array of 10 positions, and it generates the number 0, so it will go to the index 0. Next we go to the 11 and hash function again. 11 mod 10 will generate the code 1, so 11 goes to the index 1. This is the open addressing thing. We don't have additional structures like, for example, a linked list to insert the elements. The elements go all to the internal array. The first thing that I will do to display to show the hash table and a function to check if an item exists in a specific position of the array of our hash table. So the first function that we will do is the asItem. Int ht for hash table underscore asItem, and it receives a hash table t pointer, that is the table, an integer for the index, and it will return the table array at index is different from null. So this function just checks if the pointer here is at this position is null. Okay. The next function is the display function. Void ht display ht for hash table, okay, and it receives hash table t pointer, that is the table, and inside we say for int I equals to 0, while I is less than table size, we will increase the I. And if hash table as item, and we give the table and the index I, if it has item at this index, we say item t pointer item is equals to table array at I, and print f decimal, and what we will print, another decimal for the key and another decimal for the value, okay, and a new line. So I item key and item data. If it has no item on that position, we will just say printf d and empty and new line, and we give the I. After this, printf new line, just this. We already did the asItem function, the display function. Now we will do another 3 functions: isFull, hashCode, and insert. Let's do the isFull first. The purpose of the function isFull is to check if the table is already full, okay? So let's do it. Int ht is full, and it will receive hash table t pointer, that is the table, and we return table count is equals to table size. So with this we can know if the hash table is full or not. The next one is the hash code, to generate our hash code. This is a very simple function. It will return a code and an integer, right? And it is called hash code, receives an integer that will be the key and another integer that will be the size of the inner array of the hash table, okay? How many elements the hash table can handle, okay? And it will just return the key mod size. In my case, my hash function is this, but you can have another way of calculate the hash code, okay? Generate the hash code is done. Now let's do the insert function. So let's do the insert function. Will return an integer for us to know if the insert was successful or not, okay? ht insert, and it receives hash table t pointer, that is the table, an integer key, that is the key, and another for the data. And Before everything, we declare the result as 0 and we return the result, and we check first if the hash table is full and we give the table, else we do another thing. Inside we say printf hash table is full, so the user can know that the hash table is full. Otherwise we will insert. So we say item key item is equals to new item, and we give the key and the data. Next we get a index, the hash code, so hash code key and table size. Okay, we generate our hash code, that is the index on the internal array, and while the hash table has item in that generated index, we have to update the index again. So hash code index plus 1, and we give the table size. This is the linear probing. Okay, table array at index equals item and table count plus plus to update the counter. Okay, here we are checking if the position is empty. If it is not empty, we have to generate another hash code, and to do that we do linear probing. Okay, we add to the index the number 1 and we get another hash code. If the new position is empty, we go here. If not, we generate another hash code until we find a empty position. Okay, after that we insert the item at the index and we update the counter. So we did the insert function. And as I explained before in the code, let's explain again about linear probing. We have two numbers, 10 and 20, and note this image is simplified, okay, because we have data, we have the key and the data, and I'm just showing you the key. Okay, so we have 10 and we have a hash function. We give to the hash function 10 mod 10, it will generate the code 0. So we ask, as item at position 0 no, so we insert the item to 10 on this position. Next we go to the number 20 and pass to the hash function 20 mod 10, it will generate the code 0. So we go as item, yes, it has an item. So what we must do, we give the code again and we add 1, so 0 plus 1 mod 10, and it will generate the number 1. And we ask again, at index 1 in the internal array of the hash table exists an item at this position, and the answer is no, and we insert the number 20 in this position. Okay, so next we will do another two functions, the search and the remove. The function search is to search an item. Okay, so we have an integer to know if we found the item, right? So ht search, and it will receive the hash table t pointer, that is the table, and an integer, that is the key. So if it will find an item with this key on the table, we declare the result, that is equals to -1, and we return the result. Okay, next we have to generate the index. Int index is equals to hash code, we give the key and the table size. Next, while table ht as item, and we give the table and the index. While we have an item, a valid item, we check if the table at the array index and the key is equals to the given key. Okay, if it is equals, we say that the result is equals to the index, and then we break, we go away. If not, we have to update the index, so we have to generate another hash code. We give the index plus 1 and the table size, like this, and it's just this. The next function to do is the remove function, to remove a specific item. Back again in the code we say item t pointer ht remove, because we will return the removed item, right? And it will receive the hash table t pointer, that is the table again, an integer, that is the key again, and let me declare here the item t pointer, that is the result, and in the beginning is null, and return the result, and in the middle we get the index, so we do hash table search for that element in the table, right? So we give the table and the key to the ht search, and if it was found, if the index is different from -1, we say that the result is equals to the table array at this index, the item on this index, right? And then we say that in this position index in the array will be null. Next we have to update the counter with minus minus, count minus minus, okay? And then we return the result, is just this. We did the search and the remove. So now let's do our test. Let's see our main to do the test. First I create a new hash table with size 10, okay? Then I display the hash table, it will be empty. Next I insert a key 10 with the data 97, 20 and 2, 30 and 4. Then I display again the hash table. After that I will search for the number 20, okay? And if not found, I say that the number was not found. After that I remove the number 20 and then I display again. So if we run on REPL, we have this output, okay? The first is the table is empty, then we have 10, 20 and 30 and the rest is empty, and we search for the item 20, we find the item, we remove the item 20, then we display the table again, and now in the position index 1 of the inner array we have an empty slot. Well, everything is running fine. Now let's search, let's try to search for the number 30, okay? So let me copy this code and put here, and let me change this to be 30, and we will find the number 30 and 30 not found. Back again to the REPL, let me clear the console and run this again with the new code, and well, now we have search item 30, 30 not found, but we have here what is happening, right? So let's see, we have an array with 10, 20 and 30, the internal array, right? Then we remove the number 20, the key 20, and then we want to search the number 30. So we go to the first, because all of them generate the same index, this index 0, okay? We go to the first and ask as item, and yes, but it's not 30, okay? But isn't 30. So we go to the next position, as item, no, then the search ends, okay? So this is the problem, and the solution is adding a dummy item. Let's go add the dummy item. We have to change the hash table, the new hash table and the free hash table. So let's do that. Here in the code we have to add to our hash table struct item t pointer deleted item for us to know what it is. Next we have to go here to new hash table, and well, we have to add here also a result deleted item, and these will be equals to new item with -1 and -1. So we know this is a deleted item. The next thing to do is for the free hash table. We go here and well, now instead of item different from null, also we have to check if it is not a deleted item. So item is different from table deleted item, because we don't want to free the deleted item, okay? It's a global item, okay? And next we have, after freeing the array, we have to free item table deleted item. This is the right place where we should free the deleted item, okay? We already changed hash table, new hash table and free hash table, okay? Next we have to change as item, search and remove. Let's do that. Well, since we change the logic here, now we have to change the as item, because a slot is not just empty when it is null, okay? It is empty also when the slot at index is equals to the deleted item. Okay, let me put these in the next line so you can see it clear. We have two conditions: when it is null and when it is the deleted item. Okay, the next thing to do is the search. So, well, in the search now cannot use this condition, because if an item was removed between two items, and if we go there and we find that it has the it is considered as empty, the search will end, right? So we have to continue in that cases. So we have to change this, okay? And we say that this will run until the item at this index is different from null. The dummy item is not a condition for this to stop. The next thing to do is going to the remove, okay, and instead of assigning null to array at index, we want to assign the table deleted item, okay, our dummy item. So this is all that you need to avoid that problem, okay? Let's review all of the changes. Going up, we see that in the hash table we added a deleted item, okay? Then we had to build the item, so we create the item here in new hash table. Then we have to delete the item when the table is deleted, okay? So we free the item here, not here, okay? So we have this condition, it cannot be here. The next thing is the as item. So a slot now have item if it is not null and if it is not a deleted item, okay? The search now cannot consider the deleted item as a condition to stop the search, okay? Because when you delete items between, for example, if you delete the 20 and you have 10 and 30, if you want to find the 30, the 20 is a dummy item, so the search will end, okay? So we cannot consider the deleted item, okay? Just the null. And finally, we have to assign, instead of null, we assign deleted item to the slot where we remove an item, right? We did as item, search and remove changes. Now we can test. I already updated the code, so let's run these, and the output is when we search for 30 we find the element, okay? So now here let's do another test. Instead of a hash table of size 10, we will have a hash table of size 3. Okay, and let's search for an item that doesn't exist on our hash table. So for instance 40, for example. If I go here, I pass the new code and run, and we cannot reach the end. Okay, the printf end doesn't appear. Okay, let's see what is happening. Here we have a situation of infinite loop if not exists. Our case is this one. We have 10, we have a dummy item, and we have 30. But also it can happen if the array is full. Okay, if the array is full or have dummy items, not nulls, this will happen when we search for 40, for example. And we have to fix the search. Okay, so let's do that. Here in the code we go to the search function, and our problem starts here when we check if the item at this position is different from null. Now we cannot do that, just that. Okay, so let me add, for example, an integer counter that is equals to the table size, and here we will check if the counter is greater than 0. Okay, it must be different from null, and the counter must be greater than 0. Okay, also we need to update this counter, so we go here and say counter minus minus. So with this solution you can know if you already were in all positions of the array. Okay, the internal array. Let's test this. Here in the REPL, let me paste and run. And now our item was not found. We have the information that the item was not found, and the program just ended. Okay, we changed the search, right, and we did the test. Okay, one last note. In this solution it's allowed to add duplicates. Okay, if you have, for example, two items with the key equals to 10, you can have the two items in the array, internal array in our hash table. Okay, and to avoid, if you want to avoid that, you must include a search on the insert function and do whatever you want. If you want to override the item, or if you want just to leave and go away, is for you to decide. Okay, like I said, use search before insert, right? And this is the end. Thanks for watching, and hope you like it.